This is beginning section 4.2, so chapter 4, section 2 in our book, and it's about congruent triangles. And most of this unit is about congruent triangles. That's a really, really big deal for us. In this section, we're learning about how congruent figures are related and what you can do with them. But in sections after this, we're going to learn shortcuts for proving triangles congruent, which will be helpful when we write proofs. And there are proofs on the test in regular geometry as well as pre-AP, so that's going to be a big deal, especially for this unit. So let's just talk about congruent figures and corresponding parts just to get into congruence and what that means. Congruent figures are when all the parts of one figure are congruent to the corresponding parts of the other figure. So if that didn't make sense, now we're going to talk about corresponding parts, which should help clear up, this definition here. Corresponding parts are the corresponding sides and corresponding angles. Those are the types of parts that can correspond to each other. So you have corresponding sides and you have corresponding angles. So in this particular section, if we were to do a proof, we need to prove all of the corresponding parts of one figure are congruent to all of its corresponding parts in another figure, which can take a long time because even if you just have triangles, they have 3 sets of angles and 3 sets of sides, which would mean that your proof would have to have 6 statements in it about, 3 for the sides and 3 for the angles, which is a lot of statements for a proof. So let's look at this here, which is talking about corresponding figures and naming the corresponding angles and naming the corresponding sides so we can get comfortable with that. So looking at this picture, identifying the corresponding parts is going to be critical for us understanding how to do any of the rest of the unit here. So let's look in this picture, and it's all marked up. So we need to get used to this, that this right angle marking here and this right angle marking here, those are corresponding angles. So my angle A corresponds with angle F, and I can see that in the picture. So for these angles here where it says angle A congruent symbol,
all right, everybody, it's that time of day.
I can put angle F there. Sorry, ignore that PA. There we go. So angle A corresponds with angle F. Looking at the picture, see how B has 1 arc on its angle? It corresponds with the angle that has 1 arc on it over here, which would be G. So angle B is congruent to angle G. And angle C has 2 arcs. H has 2 arcs. So angle C corresponds with angle H. So those are my 3 sets of corresponding angles. Now let's look at the sides. Side AB, let's find it. Side AB has 2 markings on it, 2 little tick marks. So we need to go over here in this picture and find the side that has 2 little marks, which is right here. I'm going to call it, since they had said AB, I'm going to start here at the right angle like they did and say FG, although it really doesn't matter. So FG with my little segment bar over it because it's a segment. BC, if I look in the picture, BC has 3 tick marks. So I need to go find any other one, the one with 3 markings, which is here at GH. So BC goes with GH. And then CA is the marked with 1 marking. The one with 1 marking here is FH or HF. Since they said CA, I'm going to say HF. Although you could put FH as well. These are segments. You can change the order on them, but you need the little bar over the top just like they had on the left side. So in the top here, we've got, this is a congruent statement, which is saying one triangle is congruent to another triangle. And the order is very, very important on this. You have to name it in corresponding order. So looking at these pictures, they started at A and then went to B and then went to C. To me, it's easy to look at the angles to put these in the right order. A goes with F, so F should be the first letter for this triangle. B is next, and B corresponds to G, so G must be next. C corresponds with H, so H has to be the last letter in the statement. This is our congruent triangle statement. Now the next one I want to show you what's really, really cool about this statement is that this statement can be used to answer all of these 6 questions. All of these blanks could be filled from the statement without even looking at the picture. If you're looking for an angle, you just look, oh, A is first, what's first? F, and then you put that in the blank. B is second, G is second, that goes in that blank. So for this one here, we're going to use that and just look and see that Q and W are the first letters. Those angles should be equal to each other. So see how Q has a 65 on it, and at W, it's got this expression for its angle. So you can use the fact that these are in corresponding locations to set these equal, and then use those to find x. So 65 equals 5x plus 5. And just solving, subtracting 5 on both sides. 60 equals 5x, dividing by 5. 12 equals x. So I was able to use just the fact that the Q is first and the W is first to set up that equation. Let's see if there's another letter in our equation. Oh, I've got this y minus x. So I'm going to have to use my x. Since this is in the same problem, x should be the same value. So I'm able to replace the x with 12 because now I know that x is 12. So I'm just substituting 12 for x there. This is the side xw or wx, however you want to say that. Wx is the first 2 letters. So on this other statement, QR is the first 2 letters. Those are corresponding. So Wx should equal QR. Let's go find QR. Here's QR. QR is labeled with 6 inches. So I should be able to set 6 equal to the expression for Wx, which is y minus 12. Then add 12 to both sides. And see that y is 18. So that's how you can use your corresponding parts to find missing variables, and how you would show figures are congruent by showing all 6 corresponding parts are congruent.